So in particular, we are looking at like how radiation affects immune response, and one of the proteins which we are interested in is Galectin-1, which is basically can affect immune cells from coming into the tumor. So the tumors basically use galectin as a kind of a barrier to let from coming into the tumor, and therefore if you do not have these cells entering your tumor, it's not going to get recognized or killed by our immune system. So that makes it really hard for any immunotherapy targets to work on it, because immunotherapeutic drugs which are right now in trials are basically, most of them, you already need a pre-existing clinical immune response in them for them to work. So there has to be some kind of recognition, and these immune checkpoint inhibitors target, once they are there, then they make them more active and then make them do their job better. But if they're not there, then obviously they cannot make them come into the tumor. So we are trying a combinatorial approach where we think that if we inhibit galectin in them, then basically you bring in the T cells and then you use these immune checkpoint inhibitors to keep them active for longer. So it's kind of a double-edged targeting that will make them better and be better responsive. So we have seen this in head and neck cancers, and it's showing very good efficacy when we combine these two drugs together. So we are just trying to develop this into different models and trying to look at how better we can achieve this response. And we are also hoping that if we have a collaboration with companies now which are helping us taking it further, and maybe eventually if it works in all these preclinical models, it might even get into a trial phase of it. So that's essentially what our research is about.